Okay, so today we're going to review everything we have learned about stoichiometry, and I'm going to give you kind of a cheat sheet to figure out how to set it up. Okay, so the first thing we have to know is we have to know our given and what we're looking for. And we've practiced doing this in our previous sets of notes. And so if we're given moles, and the given is always given with some number. So if you see a number associated, that's your given. So, and what are you looking for? And then what are you looking for is normally it says how many of whatever is what you're looking for. And then you want to look at the given and what we're looking for, and are they the same substance or compound? And if the answer is yes, then we're just converting moles of one to grams of the same one. So you would put your the number of moles of your given. Your given always goes in this corner, moles of given, and then 1 mole goes here, and then the molar mass of the substance goes here. Because remember, the molar mass is always going to be equal to 1 mole. And we get our molar mass, just for in case you forgot, it is this number here on our periodic table. So if we're given grams and we're looking for moles and they're the same substance, then we're going to write our mass, our given mass here. And then the molar mass goes here. And then 1 mole goes here. Okay, now we're getting into, no, they're not the same substance. So if we're looking for moles of one and converting to moles of the other, we have to look at our chemical equation. And we are going to look at the numbers before the substance. So specifically, we're going to be looking at the exponents. So if I had H2 plus O2 yields H2O, our balanced equation looks like this. So specifically, we will be looking at the coefficient. So what you have here is the moles of the given. So whatever our given moles are, whatever's in the question. And then the coefficient moles of the given, and then the coefficient moles of what we want. Okay, and so what you need to make sure that you know there is whatever you have here is what goes here, is what counters over here. Okay, so if I've got the 3 moles of hydrogen, then down here I would put 2 moles of hydrogen, and up here would be 1 mole of oxygen, because oxygen has no coefficient, so it's understood to be 1. Okay, moles to grams, they are not the same. So we start with moles of given. So we have to then convert it. The first thing we have to do is convert it from moles of given to moles of what we're looking for. So from the equation, so everything that's in this box right here comes from the chemical equation. So we have moles of the given, coefficient of the given, and the coefficient of what we're looking for. Then we have to convert our moles of our what we're looking for to the grams of what we're looking for. So now we put 1 mole here, and then the molar mass of what we're looking for here to convert the moles of our unknown, or the grams of our the moles of our unknown to the grams of our unknown. So step 1 converts moles of 1 to moles of 2, and step 2 converts the moles of 2 to the grams of 2. Okay, so if we're doing it the other way, basically this is just doing it backwards. So grams of 1 to moles of the other. Again, it's a 2-step process. So we start with our given grams. We have to convert that to moles. So this would be the molar mass of the given, and 1 mole. And then this part is what comes from our equation, the coefficients from our equation. And so this would be the coefficient, and I'm going to just, the coefficient from our given, and the coefficient of what we're looking for. And so again, when you do this math, it's multiply across, divide down. Multiply across, divide down. And so the steps here, it's again, 2 verticals tells me that there's 2 steps involved. So the first step converts grams of 1 to moles of 1. And the second step converts moles of 1 to moles of 2. Okay, so next, grams to grams. And in reality, this is the part that's really the most important, but you had to know those previous steps to be able to really set this up. So we have grams to grams that are not from the same thing. So we have start with grams of our given. We have to convert that to moles. So we start with the molar mass of given. One mole. Now I have to convert moles to moles, because the only ratio that I really have in all of this is the number of moles to the number of moles. Okay, so we have to convert moles to moles. So now we go moles to moles, and and this is moles of given. So this part comes from our equation. So we have the coefficient for our given from the equation, and then here we have the coefficient or the moles from our equation for the unknown. Now we need to convert our moles of our unknown to grams of our unknown. So we know that 1 mole is equal to the molar mass of the unknown. So 3 steps. The first step from here to here 1, 2, and 3. So step 1 is going from grams of 1 to moles of 1. Step 2 is going from moles of 1 to moles of 2. And step 3 is going from moles of 2 to grams of 2. Okay, so let's go through the steps to solve the problems. Identify the given. The given will always include a number of grams or moles and a compound or an element. Step 2, identify what you're looking for. This normally says how many grams, how many moles, how much would I need. Pick the correct T-chart. You need to solve the problem. Use the stoichiometry help table. Write the given up on the top left of your chart. Remember, you're always trying to get them to cancel out diagonally. Write the units, grams, or moles and the compound or element on the top far right of your chart. Okay, so 1 mole equals the molar mass in grams. So grams are always found on the periodic table. If you have moles on top of moles, the number that go in the blank are the coefficients from the balanced equation, which we've talked about.